If you're looking to compare the results from one set of data with another set of data, you draw a graph, you can see if there's a relationship between them. It will be quite obvious if there is, and we'll talk about that in a minute. Positive correlation is the first one. You won't be able to read it, so I'll do it for you. Now, a positive correlation is where an increase in one set of data results in an increase in another set of data. They give us a lovely little example here. For example, if we plot temperature against ice cream cells, so temperature, ice cream cells, as the temperature increases, the number of ice cream cells also increases. It makes sense, it gets hotter, more people want an ice cream when they're out and about, they buy more, therefore more is sold. Alright? Next one, negative correlation. See that coming down? A negative correlation is where an increase in one set of data, that one, results in a decrease in the other set of data. Demo, well, if you plot temperature against the sales of coats, presumably winter coats, as the temperature increases, the sales of coats decreases. Well, that makes sense. The hotter it gets, the less likely it is that sales of coats will be plentiful. So when it gets colder, more people go out to buy coats. When it gets warmer, less people buy coats. When it gets really hot, only people like me go and buy coats because they're going bargain hunting. Next one, zero or no correlation. So zero or no correlation exists where there is no obvious relationship between the two sets of data. So sticking with the temperature theme again, the temperature against toothpaste sales, for example, there is no obvious relationship between the temperature outside and the amount of toothpaste that is sold. Whether it's hot, cold or in between, people will still brush their teeth when they brush their teeth, and that's the end of it. Alright, so we have positive correlation going up, negative correlation coming down, and no correlation where there's no relationship between the two quantities or variables being examined and tested. Right, so if there's a relationship, how strong is the relationship? How strong is the correlation? Well, that's the next little set of graphs there. Here we have a strong positive correlation. As you can see, the results are very close together, almost forming a line. Well, I can produce a line of best fit across there. So 100% pure correlation would mean that every single result would sit on one perfect straight line. Well, if you're investigating results from an experiment or an investigation, you get correlations, but they're not going to be absolutely perfect straight lines. So the correlation is not absolute, the relationship is not absolute. So that's quite strong. You have to judge it by and say, yeah, that's pretty straight, they're all in line with each other, that's a strong correlation. Now here we've got a slightly weaker correlation because the results are more spread out. If you imagine a line of best fit going through the middle of that lot, then quite a lot of them are away from that central line. So that's a weak negative correlation. In fact, I better write that here as well. So this one's going to be positive, but strong. This one's going to be negative, but it's quite weak. Right, there's this point here that's been circled, and it says, watch out for outliers, which are values that do not fit in with the rest of the data. As you can see, that piece of data there, whatever happens to be measuring, is outside the normal expected trend of a negative correlation. It stands alone. It could be an anomaly, it could be an anomalous results in a science experiment, it could be mistakenly recorded, we don't know. Either way, that result does not fit in with the perceived or seen correlation there. Alright? So the strength of a correlation is a measure of how close the points lie to a straight line. As I said before, a perfect correlation. So correlation is usually measured in terms of how strong it is, whether it's weak or whatever, or whether there's a correlation at all. Let's just restate that. Correlation is usually measured in terms of strength, i.e. strong correlation, weak correlation, or zero correlation. I threw this last bit in here because I like the look of this. I like the trainers as well. The scatter diagram shows the ages of shoe sizes, and the ages and shoe sizes of a group of people. Right, describe the type of correlation and the strength of the correlation. Now, I want to draw it in here. I can see a positive correlation, maybe not too far. I can see a positive correlation up to about there, alright? and it's a weak positive correlation. So that's my strength and that's my type. Alright, now from about 20 years old onwards there is no correlation at all. Oh, I've got a straight line, but it's not a correlation because look, people are getting older and older and older and older and older. There's a 90-year-old there, older and older and older, but their shoe sizes are not getting any bigger. So I mean that's common sense. Once we've stopped growing, our feet stop growing too. So an 80-year-old won't have huge feet compared to a 50-year-old who's going to have smaller feet. It's not going to happen like that. I mean, just go and have a look. Stop a few people, ask them, how old are you, what's your shoe size, do your own research if you want to, but don't be rude with it. Okay, so describe the type and strength of correlation. It's a weak positive correlation up to about 20 years old, after which time there is no correlation between age and shoe size because people stop growing. Give a reason for your answers. Well, I've just done all that. Going over to the next question. Right, the following information shows the marks awarded to students on 2 exam papers. As you can see, I took the liberty of drawing the graph before I started the video. So I've decided to plot the French up the y-axis and the Spanish mark along the x-axis. You could have done it any way you wanted to, really. You've got to judge the scales carefully. So if you look at my French result, the biggest is 77, so I went up to about 80. Spanish, the biggest is 62, so I went up to 70 for completeness. Lowest is 10, so I felt quite happy to start at 0. Lowest for French was 14. Again, I was still quite happy to start at 0, it just looks nicer. Plot these results, so I've done that. Tanya says that people who did well in Spanish also did well in French. Is she correct? Yes, she is. I can see a weak positive correlation. So what I'm going to do now is try and do a line, a thick blue line, no, a thick black line, straight across that little lot there. So I'm going to start here and do one of these, and that is my line of best fit. Okay, so it's rough, it's okay, it's good enough. I'll label it as such. It's called a line of best fit. Line of best fit, that's what it's called. And it's clearly there's a positive correlation, though it's not too strong, but it's convincing enough. So Tanya says people who did well in Spanish also did well in French. Absolutely right. Why? We can see a weak positive correlation between the marks scored in French and the marks scored in Spanish. That's all there is to it. Next page. Okay, this is Rob. Rob collects information on the temperature and the number of visitors to an art gallery. So again, I took the liberty of plotting. I checked out the scales and I did them an appropriate size. Okay, draw a scatter diagram. I've done that. Estimate the number of people if the temperature is 24 degrees C. Now, they never asked me to draw a line of best fit, but I absolutely have to draw a line of best fit in order to read off it, and I'll show you how to do that. Use the line document there. Definitely want to go for blue. Line of best fit. So I'm going to start about here and draw all the way through to about there. Alright, so plant it there. Right, that's that. I'm quite happy with that. That is clearly a negative correlation. We might have to talk about that later. See what he says about that. Go for my red now. Now the question says the number of people, work out the number of people if the temperature is 24 degrees. Now I know I've got a result of 24 in the table anyway, so this is not an exam question. I'd say this is a mistake there, or rather more like an oversight on the part of the person who wrote this question. I can say categorically 24 degrees, 310 people were in the gallery. I can read it there. Now assuming that 24 wasn't there and that was yet another, say 23 or a 22 or even a 20, then I'll still draw my line of best fit and read off it. So let's show the examiner how to do that. Alright, do it in red as well. Start from 24, draw the line to the line of best fit, and then turn left and read it off the scale. I'm going to stop there. I'm also going to make it absolutely clear. I'm going to draw arrows as well to show the examiner what my brain and what my eye has just done. So 24, hit my line of best fit, turn left, 290. That's what I make that. So from my line of best fit, I'm going to make it 290 people visited the gallery. Alright. I've got to estimate the temperature if 350 people went to visit the gallery. That's better. There isn't 350 people anywhere in the data there, so I'm very happy to do this. Taking my line again, let's change colour, so that's a different question. Right, 350 is right there. Hit my line of best fit and then climb down. Not perfectly accurate, but that will do. Show the examiner what my eyes are doing. Oh, red again. No. It's got to be blue. Try and go over that a little bit better. Okay, so going that way and then reading down. What do I have? So when the temperature's 350, I'd expect about 23 people to be, no, not 20, I expect it to be 23 degrees C outside, sorry. So 350 people indoors. It must be quite warm outside there, because not that many in the gallery. Now Rob, bless him, let's go green. Rob says he is sure that there's two sets of data that are incorrect. Identify these on your graph. Well, that is an outlier. Okay, doesn't fit with the trend as seen in the line of best fit, and that is an outlier as well. That doesn't fit. So I've identified these two pieces of data. Alright, very nice. Last question and end of topic, taken straight from the assess and also from the exam part of the assess as well. Again, I've taken the liberty to plot these points. I've taken my Starling. I went 21 along here and 40 for his wingspan. I went 21 and 40, and there's my little Starling there. I don't have to label each point Starling, Blackbird, Blue Tit. That'll just make the graph very, very cluttered. So copy and complete the scatter diagram. Opposite, I have describe the strength and type of correlation. Well, I can see that's going to be positive. And I'm going to go for weak. Not a perfect line by any means. Is it strong? No, actually I've changed my mind. I'm going to call that a strong correlation. This one's a little bit out of place, but why should that destroy everyone else's lives? Right, it's a positive, strong correlation. So I think I'm happy with that. Draw a line of best fit. Okay, let's go for it. So we'll have that one there, and let's do it in blue. Stands out nicely. Line of best fit. I'm going to start about here and take it about there. Actually, it's a lovely correlation, isn't it? Let's just take it all the way, and I'm going to stop there. Back to the pen. What's it say? Draw a line of best fit. Yeah, I've done that. And then it says use your line of best fit to estimate the wingspan of a thrush whose length is 20. So the thrush is 20 centimeters long. He'll have a certain wingspan. Let's go green on that. 20 centimeters long. That's how big the bird is. Hit the line. Oh, I didn't use a stupid. Oh dear. Let's rub it out quickly. Right. Hit the line. Let's go darker, actually. Red stands out. Right, red. It's gone blue anyway. Hit the line, turn left like that, straighten it up, and stop. Right, showing the examiner what my brain is doing. This time I will do red. I'm reading up the line, turn left, and read off the wingspan scale. And what do I get? Use your line to estimate that. I see that as 33 centimeters. So if you're a 20 centimeter bird, you're going to have a wingspan of 33 centimeters. Now, last bit. It is not sensible to use your line of best fit to estimate the wingspan of a pigeon whose length is 41 centimeters. Well, actually, I can extend my line of best fit, go to 41, hit my line, and turn left. Bad idea. The reason being is because the data stops at this point here. So here my data stops. Beyond that, I can't guarantee that the longer the bird, the bigger the wingspan. So it's a bad idea because it is outside the given range of data. Alright? There is absolutely